we just did this. Central angle. Yeah, you better look it up. You want phones ever? You better start having pages in front of you and looking answers up if you can't remember. Here. Should have like a phones, no phone. And every time you answer a question, I'll make a check under the phone. Every time you can't answer a question, I'll make a check under no phone. And we'll see where you ever use phone.
Where she has like this thing, it's like basically for the class, like you're giving him ideas. Why are you giving him these?
Yeah, some teachers have you put phones up, or you have like some teachers make you keep them in your backpacks, and they take backpacks in those sections of the room. Again, I used to be like, I never did that, but like with my 1A kids, I was way more strict, and my geometry kids, I like to think that you guys are stronger students. That you care more, but you have definitely proven that's not the case lately. So, what do you think it is? So we did this well, actually, you got quizzed on it already, but it's not going away anytime real soon. So if you have the center of a circle, and if you have an angle where the vertex, which is basically the pointy part of the angle, is that center of the circle, that is called a central angle. So we learned that last class. We're about to learn today a new type of angle. Oh, and what did we say about the measure of a central angle relative to its arc? So I don't know what that is. 30 degrees, let's say. What's true about the measure of a central angle relative to its... Oh, so what's the arc of the circle relative to that angle? What is an arc? Yeah, you use the endpoints of the angle. So the arc is the part of the circle in between the endpoints. Now, we did say that it could be in either direction. So we talked about a minor arc and a major arc. So depending on which direction you go, you could be talking about different arcs. But regardless, you're using the endpoints of the angle to determine the arc. Oh, and we said that what's the measure of the arc? The blue arc, we'll say. The minor arc. It's the same, right? So for a central angle, the measure of the arc matches the measure of the central angle. All right. Now to today's lesson. So turn, what page are we on? 215, page 215. So I gotta go backwards for a second. There. So now we are learning about these guys. Inscribed angles. There, we'll just start with that. So an inscribed angle, or really the definition, look up those meanings sometimes like that. So an inscribed angle, or really just the word inscribed when it comes to circles, or probably other parts of geometry, but mainly it's for circles. Inscribed means the vertex is on the circle. You see that word inscribed, whether it be, could be an inscribed angle, an inscribed triangle, an inscribed quadrilateral, any shape, polygon that has the word inscribed in front of it, means every vertex, every corner is going to be a point on the circle. Not the center of the circle anymore, a point on the circle. These are some definitions. They don't really come into play. I'm not really sure what the point of them is. Like you could have a inscribed angle that goes, one of the sides of the angle goes through the center of the circle. The center of the circle could be inside the angle. Center of the circle could be outside the angle. I don't really understand why they're showing you that. It, I don't know, doesn't really come into play. So this does come into play. Actually, this is probably the most important thing. So when you have an inscribed angle, we said the measure of a central angle is the same as the measure of the arc. The measure of an inscribed angle, so angle 1 is the inscribed angle. The measure of the inscribed angle is half the measure of the arc. So for example, if AB, let me come up with a number that makes sense. If AB is a 150-degree arc, then the measure of angle 1 will be 75. The opposite would be true. If the measure of angle 1 is 75, then we'd multiply it by 2, and we can calculate out the angle of, or the measure of the arc. I'm about to show it's in your book. That's what all this is saying right here. So it's showing you it's color coordinated. So the arc is in green, so that's the arc. The angle is in red, so those are the angles. So the measure of the angle is 1/2 the measure of the arc. And then if you have to go the reverse direction, the measure of the arc is 2 times the measure of the angle. That's the number one thing you got to know from today. And we'll use that in a, but if you really, 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 really get that down, really the only thing you need to know. So the next theorem is one of those theorems that I'm like, you don't need to know that. Like that's a dumb theorem. It's math people creating stuff that you don't need. I don't know. Maybe they get their name on it. I don't know why. So now let's look at the next theorem, and I'll show you why you don't need to know it. This is saying if you have two angles, and again, remember we determine the arc based on the end point of the angles. So if you'll notice, both of these angles have the same endpoint, D and A. The green angle ends in D and A. The orange angle ends in D and A. What it's saying is if two inscribed angles have the same endpoints, or basically they intersect in the same arc, then they have the same measure. Here's the thing. You could memorize that. Two angles that have the same endpoints, that intersect the same arc, have the same measure, or you could just think about it logically. If we know the measure of this arc, let's say we don't even number it with x. What is the measure of angle C going to be? What would we do to get the measure of an inscribed angle? We said we multiply it by 1/2 or divide by 2 works, right? So the measure of angle C, if it's half of that, is going to be x divided by 2, right? Well, what's the measure of angle B going to be? Because it's the same arc. What's the measure of angle B going to be? Same thing. It's the arc divided by 2, right? So it's x divided by 2. So again, you'd come to that same conclusion if you just understood this first theorem. That the measure of the inscribed angle is 1/2 the measure of the arc. So if you want to memorize a whole bunch of stuff today, you can. Because they give you like, I don't know if it's 3 or 4 that we get through today. They're all based on you understanding that one first theorem. So any questions on that? I think the next page is the problems, maybe. I don't know if we have another theorem first. Let's see. Let's see. Yeah, so go ahead, do the first 2 examples and first 2 check marks. They're not very difficult. I'll give you a couple of minutes. Need coffee? I had coffee. I thought you were gonna say honey. I think it's supposed to be this. It's like hot tea with honey in it.
No, like, you know, like, no, like when, no, when your throat hurts, like when you swallow, like you can like hold it. It'll stop for like a minute. No, I'm being serious, like, cause I looked it up and it won't. They rolled it off.
I'm not pressed to buy into that. We'll go to my menthol. Menthol helps with it too. That's my thing called. That's the other thing that drives me crazy right there. Why don't you explain to everybody what drives me crazy? You kids act like I just don't create these rules and that I'm not serious about them. I need to introduce myself to your parents. Anytime a student transfers in, I really should be that. I already introduced myself to one parent.
Oh, you want to see that? Why is this like? Yeah, it's set up, but I still know it.
I don't think it's that weird, personally.
Okay.
We're about to find out. Let's see. What are you talking about? Example one? We're talking about example one or the check? Oh, I think it's weird. It's got more lines, I guess, than just two. That's because there's two problems. They use one figure for two problems.
Oh.
Yeah, it's for the. Well, I shouldn't. I mean, like they're trying to do an A and a B. A and B. They just didn't want to draw two separate circles. Let's see. Sometimes I think this is a lesson where having maybe a couple different colors would help you if the figures get pretty confusing. There. So that maybe if you were struggling will help you see which angle they're matching up with which arcs. Oh, some people last class too. I did not. Nobody did this in fourth period, so I don't know if anybody in this class is doing it. Some people in fifth period were really confused about other stuff. They were like making all these assumptions about other parts of this circle. There's nothing else we can say about this circle other than what we can prove mathematically. So we'll go through that too. I didn't do that in fourth period, but we did it in the fifth period, so we'll do it again in this period. So let's go ahead and start solving. So it wants to know what is the measure of arc CF. Little tricky to tell, but that angle that I outlined in blue is the 40-degree angle. So that 40 is kind of like out in the middle of nowhere, which is not great. Like they should have probably written it outside the circle and drawn a little arrow in since there's a small space there. But regardless, the 40-degree angle is angle D. So again, CF is the arc that corresponds to angle D. Those are the endpoints. So what's the relationship? What do we do to solve for CF? Yeah, we just multiply by 2, which is what they're doing over here. So they're 2 times the measure of angle D is how you would fill that in. And then you would say, okay, well, then that's just 2 times 40. Or final answer is just A.
I was confused because I didn't know.
Yeah, and again, I'm never concerned about how you fill in their blanks as long as you're getting to the end answer of whatever they're asking for. The measure of that is A. So now, measure of angle C. Well, now we're going from the arc to the angle. So we just do the opposite. We know that the measure of the measure of arc DE is what? Oh, we write 98. We know to get to the angle that has the same endpoints as the arc, that relationship is to do what? Yeah, multiply by half, divide by 2, same thing. That's it. Now, in past lessons, when we've done really easy examples, I have not put them on the quiz. I said those are too easy for the quiz. Normally, though, that's because they were old concepts that you should know. Like, you should have known what a circumference was. You should have known what a diameter was, what a radius was. This I'll put on the quiz. So it seems super easy, but remember, when you have 7 or 8 different problems, a bunch of circles that look kind of similar, just make sure you keep all of these different things straight, because there will be 1 or 2 pretty easy problems on the quiz. Next problem, check. Same concept. I'll give you, if you didn't already do it, if you were confused, hopefully now that we did the example, you can finish it. I'm going to go ahead and start on it, like by just drawing stuff in first. So I know that angle here matches with that arc. This angle here matches with this arc. So again, that just kind of helps me match up the angles and the arcs. So they want to know, what is the measure of angle B? Well, angle B matches up with what? Arc AD, right? So what's the relationship? The angle is what? Half the arc, right? So you should have gotten 20. Now, opposite, we want to know the arc going from an angle. So angle D matches up with arc BC. So opposite relationship, should have gotten 128 for the arc BC. Again, both pretty easy. There won't be a ton of problems that easy, but take advantage of the one that's on there. All you got to know is either multiply by 2 or divide by 2, depending on which direction you're going. Any questions on that? All right, so I'm going to show you this very quickly. I would not be putting anything on a quiz like it for my quiz. I would not be surprised at all, though, if you saw it on like the end of the final exam, basically. Maybe even if you take SATs or ACTs, and if you're really wanting to get into certain colleges, this would be a similar kind of, whether it's a proof or not, I don't know, but it'd be a similar kind of logic you would have to be able to use on those. We learned a couple of ways to actually prove this. I'm going to do it differently than the way they did it, and then I'll explain what they did. The way that I'm going to do it is the way that it makes the most sense to me. So, what do we know based on those congruence markings? What do the congruence marks tell us? Which ones? So we know arc PQ. I'm not going to draw in the lines on the arcs because it gets kind of messy. I am going to draw them in on something else. We know those two are congruent. And we know these two are congruent, right? So those arcs are congruent. But what else does that tell us? We just learned and got quizzed on yesterday. Say it again. Well, the arcs are the same measurement, but there's something else in it. So that is correct. They have the same number of degrees, but there's another thing that goes beyond that we learn. If the arcs are the same length, what else do we know? What's the word for it? Can I say it? What's the name of it? Say it again. What's the word? So what is the line that goes across the circle between the 2 points? Chord. Right there. Chord. So if we know that those are the same, the arcs are the same length, we know the chords are the same length. That was from last quiz, which means those chords are also the same length. So here's the way I did it, differently and again than the way they're doing it. Can anybody tell me yeah, it tells us what we're trying to prove, so I'll go ahead and refer you to that. We're trying to prove that those two triangles in there are congruent. So somehow we got to prove there's two congruent triangles. Can anybody tell me another step that they see? I guess you can use what they did for you in the proof, but I did not use their proof. I did it totally different way. And I mean, totally different. By the way, I like that. We're trying to prove that these two triangles are congruent. PQR is congruent to PTS.
Well, because two of the sides.
Nope, that's not enough. Two sides is not enough. How can we prove triangles are congruent?
They're the same.
There's 4 ways. Remember back when we did the 4 ways?
Wait, angle, side.
Angle, side, angle is one. Angle, angle, angle is similar, not congruent. But what's the other one with all the same letters? So side. So let's write these down. We could do side, side, side. We could do angle, angle, side. What else? We could do side, angle, side. Side, angle, side. Yeah. We cannot do which one? We cannot do the profanity one or the backwards version of the profanity one. So we can't do that one. We can't do angle, angle, angle. So there's one more. I think somebody just said it. So those are the 4 ways. So somehow we got to prove some of those. Well, really just one of them. Once you prove one of them, then all of them are true. I went ahead and to me, the first one is the easiest one to prove. So I'm telling you which one I use. That's not the one they use. If you'll notice, they start talking about angles. They start doing something with angles. To me, that one didn't jump out. What's true about arc PQR? What's true about arc PQR? Back row.
Back row. You're back. Oh, I thought you said back.
Nope. I said that.
PQR.
What's true about it? What's it made up of?
Wait.
No, just the arc. Just the arc. What's it made up of?
Can you stop singing here?
What's it made up of? What's it made up of? Just literally tell me, what is PQR made up of? It's made up of 2 things.
Why'd you say
2 arcs, right? It is. It's made up of 2 arcs. It's made up of the arc that has 2 congruence marks and 1 congruence mark, right? Well, what's true about PTS? It is. It's made up of the same 2 arcs, right? PQR is made up of the same 2 arcs because they're congruent. It's made up of the same exact two arcs. So therefore, we could say this arc from P to T to S is congruent from P, or is congruent to P to Q to R. If we say that, though, if you'll notice, the endpoints of that arc are P to R, so that chord that is associated with that bigger arc has to be congruent to this chord that's associated with the other arc. That's the way I saw it proven. So for me, I actually use this. I use side, 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 because that tells me every side is congruent, which means a triangle. They actually did something with the inscribed arcs, and they said that because these two arcs are congruent, that means these two angles have to be congruent because their endpoints are the same to, like, their endpoints are arcs that are equal to each other, congruent. So that means the angles have to be congruent to each other. That's how they did it. Again, just sometimes there's multiple ways to do it. Just kind of walking you through some different logical steps that you may see on the upcoming final exam or ACT, SAT.
Are you gonna do this? I shall review something in the text. Like this? No, I meant, are you gonna put this?
I said I'm not doing anything with proofs. The only reason I showed you that is for the final exam. I could see something like that being on there. Or, again, those of you that want, I mean, I don't know how high your sights are set, but if you ever go, who has Avid? Anybody have Avid? If you go down the hallway, what hallway are most of the Avid classes? Are they all in the same? I think it might be K. I went in K. They've got, and actually it's probably in multiple hallways. They'll probably see it in the hallways. They've got a poster that lists out a whole bunch of different colleges and what the GPAs are to get in, and the SAT scores and ACT scores. And I'm telling you right now, you want to get into some of those colleges, you better be doing well on the ACTs and the SATs. And this is the kind of stuff you'll see on them. Those scores were way higher than the scores that I hear kids talk about when they take them. So I don't know a lot of upperclassmen, so I don't hear about a lot of scores. But the ones that I do aren't repeating numbers nearly as high as I see on those posters. And that's because you have to practice sometimes for these different exams. All right, so here's your next theorem. Again, you really understand the concept that we just learned in the very first theorem, you don't have to memorize this. Don't understand it, then you need to memorize this. What it's telling us is, if we have a triangle that is inscribed in a circle, and one of the chords of that triangle is a diameter, so FH is a diameter, what it's telling us is the inscribed angle has got to be 90 degrees, or basically it's saying it has to be a right triangle. That's what all this stuff is saying right here. The inscribed angle of a triangle that intercepts a diameter of semicircle, blah, blah. It's just saying if we use the diameter and we create a triangle. So, as another example, it's saying no matter where I create the triangle, let's say I draw it from here to here, it's saying that also has to be a right triangle. If ain't one down here, bless you. Do it in another color. Let's say I create it down here. They're saying it has to be a right triangle. So again, you can memorize this and just memorize, okay, anytime I have a diameter, if I make a triangle anywhere in the circle, then that's got to be a 90 degree or a right angle, or right triangle. So you could memorize it. But let's think about why it has to be that. So, if I have a diameter, so the endpoints are F and H for that diameter, what's true about the arcs associated with the diameter? What's true about the arcs associated with the diameter? Did you just say please? That's perfect.
No.
Learning that?
It's not always going to stay in there.
It's cold. What's true about the arcs created by diameter? So again, forget that picture. I draw in a circle. I tell you that's the diameter. What's true about the two arcs? They're the same, but what are they? You should know exactly what they are. The arcs are not angles. The arcs are the curved part of the circle. What's true about the two arcs? They're 180, right? We just split 360 degrees in half. They're semicircles. So anytime you have a diameter, so here's the part where if you understand this, you don't have to memorize it. Anytime you have a diameter, it's going to create two 180-degree arcs. What a diameter does, splits the circle in half. So if we're then going to inscribe an angle, what's true about an inscribed angle and the arc associated? We just learned. You have an inscribed angle. What's true about the inscribed angle relative to its corresponding arc? It's half the arc, right? So if we're inscribing an angle, and again, key is that's the diameter, well, we know the arc is always going to be 180 degrees. We just said for any diameter, the arc is 180 degrees. The inscribed angle has to be half of 180. That's why it has to be a right triangle. No matter how you draw it, we're always going to be taking half of 180 degrees, which means we're always going to come up with a right angle, which means we're always going to have a right triangle. So, again, you can memorize all of these, or you can spend a little time trying to figure out why they're true. And if you understand why they're true, you won't have to wind up memorizing hardly anything, just the first theorem. I don't, let me see, I'm not sure if there's a practice problem yet on that. Oh, here. Not yet. So here's the next one. Kind of the same thing. You could memorize this, or you could spend some time trying to think about why it's true. So here's what this one's saying. If you have an inscribed quadrilateral, what's quadrilateral? Four-sided figure, right? So we've inscribed a four-sided figure into a circle. I zoom in. Nope, that's all I got. It says the opposite angles are always supplementary. What's supplementary mean? They will add up to 180, right? So again, just memorize that if you want. Opposite angles of an inscribed quadrilateral are always going to add up to 180. Or let's think about why that's true. For angle M, what is the arc corresponding with angle M? The cut. So what's the arc corresponding with angle M? Use the two endpoints of angle M and tell me what arc. So angle M would be from here. What are the endpoints of those two segments? Keep going, keep those red lines going out. What do you hit? L and N, right? So the arc associated with angle M is L to N. That's the arc. Right? Now let's. Oh, you know you're looking.
Oh, I thought you said M.
So, well, M is the angle, the arc associated.
I thought you said
So now, What is the, we'll do this in green. Let's look at the opposite angle, which is angle K. What's the arc associated with angle K? Yes, what's the arc associated with angle K? It's still LN, but it's actually technically LMN, right? Well, what did we just make when we outlined those two arcs? The whole circle, right? Which is how many degrees? Say that again. So we just outlined 360 degrees for the two opposite arcs. What's true about an inscribed angle relative to its arc? Same thing we said every single time. What's true about an inscribed angle relative to its arc? Half, right? So if the whole arc is really 360, the angles are half of the 360, then they have to add up to 180. So if we know that the arcs are going to total 360, the angles have to be half of that because an inscribed angle is half of the arcs. That's why they always have to add up to 180. Because no matter like we can do it with the other angles. Let's say we did the opposite or the other way with L and N. So for angle L, here's the arc. That's angle L. For angle N, the opposite angle, here's the arc. Again, we just outlined the circle. Same concept. An inscribed angle is half the arc. So if we add up those two inscribed angles, they have to add up to 180 because that's half of the 360 that are the two arcs that we just outlined. So again, I'm trying to make it easier on you because there's a whole bunch of these theorems to memorize again, just like the last quiz. I don't know how much of this, just kind of look at what they did next. We did a lesson, if you'll remember, way back when on a circumcenter, an incenter, a centroid, an orthocenter, like all those things. They have a relationship with circles a lot of times. So specifically for this one, if you look at that word right there, circumcenter, if we created the circumcenter, or when we created the circumcenter before, we said that's the point where if we take all of the midpoints of each side, we draw right lines at right angles, and we see where they meet. Good thing I didn't wear my Louis shirt today. So if we draw lines where those meet, so again, we're drawing through all of those. Oh, that's not actually what they're doing. That's not. Steal my food.
Yep.
So when they meet right there, all those perpendicular, you did order a hoodie. You did order a hoodie. So
How much?
hoodies are 35.
Okay.
You got a small, I think. She probably took the last one. So we said that point, that circumcenter point, is the same distance from every vertex. Well, that's exactly what a circle is, right? The center of a circle is the same distance from every point on the circle. So if we make the center of the circle the same distance from those three points, we can draw what's called an inscribed triangle using that circumcenter type. What did you get? Candy?
Yeah, we got it.
Mm-hmm.
I'm gonna give you the money tomorrow.
All right, that's fine. Yeah, I just sent the email today to the teachers. I've been telling all my ninth graders, so there are some ninth graders. So again, I don't know how much they're going to do with that, and you can do the same thing for some of those other points. A lot of those points have to do with circles, like not just triangles, but circles as well. So we'll see if they come up more. I at least wanted to mention it, even if it doesn't come up, because it could come up in other tests. Not because I'm not doing anything with it on my quizzes, but let's see. All right, so let's go ahead, try to do this one on your own, and then I'll tell you how I'm going to make it more difficult on the quiz. So go ahead, try to do that example. It's pretty easy. Oh, actually, no, it's not. This is not as easy as some. Let's see how you guys do. I'd try to do it without what they did, but if you want to use what they did after that, you can't figure it out. I will tell you this is, you need to put a little asterisk next to this problem, because I like this problem a lot. There was another one actually that I meant to tell you to do that on. I forget which one it was. Where did we? I don't remember how far we got there. You had this in your book, so I'm going to kind of, oh, yeah, this is the last one we did. All right. So what was the other one I was saying? I don't remember. Oh, yeah.
I'm taking the calculator.
Doesn't help man. If you don't have phones yet, but act like you have. That's why I worry about you kids. That's why I worry about you kids.
My messaging system.
Yeah, it's not in these.
What's done?
Huh?
Oh, darn. I put my hoodie on.
I won't have to pay the prayer.
I have another pink one. Okay. Like the pink. Just drop seconds.
Wait, can I try it on?
Mine?
Okay, merch.
I thought you meant my pink cake.
Go buy my merch.
Link in the bio. Okay. Which size? 1, 2, 3, or 4.
Sometimes I feel like
I thought you were gonna take my portion.
It's like, we needed this
3 years ago.
like tries to make us do muscle memory because we did not use the calculator.
Can I add your number?
oh. So you guys have gotten into a habit, and I kind of told you that sometimes this is the only way to do it, of just setting two equations equal to each other. Wouldn't have worked in this one. Hopefully you didn't do it that way. I mean, they didn't do it in this one either, so you should have known not to do it. But now we need to figure out why are they doing what they're doing. So literally.
You're not funny.
This is when the quizzes get tough. So now we're bringing in two like little equations that look really similar to what we did in some of the other problems. But you don't set them equal in this one. So remember, you've got to think about why things are true. What's going on? Don't just set two things equal to each other. What is true about Km? Even though it doesn't tell you this. Well, actually, it doesn't really tell you. But it's a diameter. Km is a diameter, right? So we know that the arc here is what? That's the 180. So then if we have an inscribed angle, which is angle L, what's the measure of angle L? Angle L. It's inscribed angle. Inscribed angles are what? Relative to their arc. 90, right? So the inscribed angle is half the arc. So that's a 90 degree. So it's 90 degree. So that's what they're doing here is they're saying, okay, well, I know that if this angle L is 90, angle K plus angle M has to also be 90. Because remember, all three angles of a triangle add up to 180. So if this one's 90, those two have to add up to 90. So that's what that first line is stating. Now they're just substituting in, well, I know angle K is this, I know angle M is that. Again, they just have to add up to 90. Now you just solve it out. So again, oh my goodness gracious. Where were you at? Who pulls you out? Who pulled you out? Huh? I don't know why he's pulling you out of my class. All right, I'll find out. So now you just solve it out. What's the answer? 13 x. Then we would add that. So 13x is 104, I think. Is that what you guys got? So what that 8? Yeah, so looks like that would be 8 for x. That's not the final answer. So if we plug that in, so 5 times 8 subtract 4 would be the measure of K. So 40, so 36 should be the measure of angle K.
Oh, because you have to substitute it.
Yeah, because they wanted the measure of the angle. We just solved for X. Well, that's the measure of angle K right there. So once you solve for X, you got to plug it back in. Yeah. Yeah, that's what that is down there. Okay. Because we just went through it.
Because, yeah, but do you not know algebra?
So again, this, yeah, you highlighted it, that's 180.
But this is.
But this is in right an inscribed angle at half arc.
Yeah. So why did?
Since the triangle has a 180. So the whole triangle is 180, subtract out 90. You could say all three together add up to 180. Right? Because the three internal angles of a triangle add up to 180, right? So we could have said angle L plus angle K plus angle M equals 180. Because all triangles, right? All three angles add up to 180, right? L is? No, they add up to 90 together. Because what is L? So if this is 90, we'd subtract 90 from this side, subtract 90 from this side, so K plus M equals 90. So try to do the check if you didn't already do the check. It's the end, actually. I think we have one more lesson, maybe. This may be the last lesson in pages. I don't know. Wait, no, it isn't. No, it isn't. I'm not gonna let you just hear me. Again, I have people that have been absent that haven't formed pages out yet. So I'm you term out. If I get sure that they don't show up. Unless I have some up here, which I did actually have some that somebody left. Here. These look like somebody left or maybe somebody left. And, all right. So again, you should have put, if you don't know what an asterisk is, like one of those things, because that problem I like. Mainly because you don't just set two things equal to each other. You got to kind of think about it. And I won't even make the other ones so easy that you just set two things equal to each other. You will always have to figure out what to do on my problems on the next quiz. There will be at least three things, even on an easy problem. So you have to figure out which two things you would set equal to each other. While you guys are working on that, let me see if I can give you some of the problems. I didn't do this for the other classes. Time for you to watch. Nope, that's not a watch. Don't believe I'm going to do that. Let's see. Find. Oh, yeah, so this probably.
There's a 146.
Probably. It's one of those two, probably. Oh, that is the last. So actually, the next example is the last thing. So we'll save that. Oh. Bless you. So 219.
Actually, not really. They used to be longer, but they were great. Girl, this is long.
Yeah. Girl, I have no.
219, 220. 1 through 10 on, what is that, 220?
Get nice.
221. I don't know where to put the next set of problems. Red. All right, so I'm gonna go ahead and write some of the problems up.
That's fancy word.
Wait, we have to start with the thing.
There's no 5-star pro that is necessary.
Mm-hmm.
Mr. Gill,
Yeah.
your favorite student?
Oh, I don't have favorites.
Oh, it seems like there's a favorite.
I think so.
Haley is ghost student.
No, my All right, so here are your problems that you're responsible for. We might have some